thank you very much. It's a real pleasure to see so many friendly faces, people that we know for a long time, and new friends. We actually are very privileged to have a number of both honorees and past honorees. So today we have with us the keynote is a past honoree, James Green, as well as Seifi Gassemi, a past honoree, John Televantos, and Marilyn Simons. So thank you very much. A round of applause for our past honorees. So I would like to speak a little bit about the students. Shah already mentioned some of them, but I think it's worth saying because without them, this would not be a full event, a complete event. So we would like to acknowledge the presence of students and professors from Yale, Pace, Columbia, Rutgers, Stuyvesant High School, CUNY, NYU, Cooper Union, NJIT, and other fine institutions. I'd like a round of applause for all of them. So in the year that we celebrate the 56th anniversary of the Apollo program, moon landing, it is a real privilege for me to introduce the keynote speaker, Jim Green. Jim dedicated 42 years to NASA, retiring in December of 2022 after a career that shaped the future of planetary exploration. He earned a PhD in physics from the University of Iowa in 1979, beginning his journey at the Marshall Space Flight Center and later the Goddard Space Flight Center. Under his leadership, NASA extended missions such as Mars Odyssey, Mars Reconnaissance Orbiter, ESA's Mars Express, and the Spirit and Opportunity rovers. He also launched landmark missions, including Maven, Phoenix, Curiosity, Insight, and Perseverance. His contributions earned him NASA's Exceptional Achievement Medal for the New Horizons Pluto flyby and the Distinguished Service Medal, NASA's highest honor. Beyond administration, Jim has written over 125 scientific papers and 80 technical and popular articles, coordinated NASA's involvement with the Hollywood film The Marshal. And in 2017, he had an asteroid named after him, James Green, in his honor. Finally, Jim Green has been a co-organizer of the annual CME annual symposiums since 2018. Please join me in welcoming a visionary leader whose work continues to ignite the world of science, Dr. Jim Green.
Thank you very much, George. It's really a pleasure to come and talk about space. Obviously my favorite topic, spending a whole career in that. And George has asked me to talk about some of the unique things that are happening in low Earth orbit. So I'm going to talk about some of the research that's done on the International Space Station. Now, for many of you who may know this, but maybe some of the younger students in the crowd don't, but in the last 25 years, there have been people that have been living off Earth in low Earth orbit, and that is on the International Space Station. In those 25 years, these astronauts have performed more than 3,000 experiments. Experiments in the area of combustion science, fluid physics, fundamental physics, materials science, food production, cellular behavior, and microbiology. They have really set up the next generation space stations, which are just around the corner. I'm going to talk about a couple things that we did on the International Space Station relative to human biology, the chemistry of life, if you will. During my early career at NASA headquarters, NASA was trying to get the National Institute of Health interested in doing this kind of research on the International Space Station. But NIH was not interested in helping us work on astronaut health. That's what they thought. NIH thought, well, you're talking about such a small percentage of people that are at their peak of their performance, they're type AAA personalities, and most humans are not like that at all. Why would we be interested in the health of these astronauts as they live and work in space? And then something remarkable happened. It's called the twin study. The twin study is Mark Kelly, Scott Kelly, two astronauts, identical twins. This is the perfect situation to leave one on the ground and fly the other. A control, if you will, in which when you return Scott Kelly from space, you can compare right on down to the gene level what was happening biologically, with a degree of certainty that space contributed to those changes. So they were thoroughly looked at, compared, intercompared, and then Scott Kelly spent nearly a year in space. Now the time was decided to be a year for the simple reason it's going to take that on the way to Mars, and certainly almost a year coming back from Mars. So if you're in space that long, what does space do to the body? What happened was absolutely unbelievable in terms of these comparisons. When Scott Kelly returned, we found that well over 6,700 genes had effects. Some were expressed, meaning they became active. Some were inhibited, meaning they stopped working. All right, right on down to the DNA level, these genes were being affected by the environment they're in. A couple things that were really quite fascinating is Scott Kelly's telomeres got longer. Well, this is really important for cell division, because if you've got some repair to do on your DNA, those telomere pieces are used to fix the DNA and create identical cells. And this is why telomeres are thought of as important for longer living and reproduction of your cells correctly. But there were also some other problems. Scott Kelly was in orbit for nearly a year at the age of 51, and when he returned, his immune system had aged by 30 years. By 30 years. And of course, that didn't happen to Scott, or Mark Kelly, who was down on Earth as they were doing the comparison. So we didn't know how Scott Kelly lost his immune system, but within a month, his body repaired it. And we didn't know how it repaired it. I now had what I needed as chief scientist to go to the National Institute of Health and say, wouldn't you like to know how to repair an immune system? And of course, this is just before COVID, when the enormous immune system problems that the elderly had managing and trying to handle such an invasive virus as COVID-19. They signed on the dotted line, and we now have an MOU where we're going to work together on more experiments in this particular area. So this was a fascinating opportunity for us then to recognize that the epigenetics, the environment that we're in space, can be used to be able to perfect a variety of drugs, create a variety of procedures, do a number of things that will aid humans here on Earth to live a better life and perhaps a longer life. Since 20% of the people in the United States die of pneumonia, flu, and other infectious diseases because of an immune system that's not working properly. What we're finding out then is space is a wonderful opportunity to do this type of research. Research that here on the Earth takes years and decades now can be done in the International Space Station days and months, where rapid changes then can be monitored and mitigation strategies can be implemented, and we can really understand the processes that the body goes through that change the way our genes interact. Another experiment, which I happen to be involved with right now, just came back from the International Space Station, and it attacked the problem of autophagy. Autophagy is a process that, once kicked in, cleans up the garbage in your cells. This is incredibly important. Our genes that are expressed interact with the RNA saying, I need you to make a protein. The RNA makes that protein, but if it makes it incorrectly, it cannot use it, and it just clutters up the cell. So the cell then becomes an object that's not working, and then all of a sudden there's a decision point for which that cell says, I must die. And senescence kicks in, and you have cell death. And if it happens throughout the body, you have organ failure, and that's a problem, of course, of not kicking in the autophagy genes. So we've been launching organoids, a collection of cells that are out of humans that then represent that organ, and then we inject them with a variety of nutrients, and we see how things change. And the results are not in yet, but I hear there's some exciting results to be had. So this is just a fantastic opportunity to move forward in this area. NASA also does a variety of research in growing plants in space. All right? And it has invented some really creative elements. Some of these elements are, for instance, vertical farming. Instead of growing things flat, you can actually use that third dimension. You can grow plants in hydroponics, a water solution, and the chemistry of what you need to keep these plants going and thriving has to be percolated through this water mixture for the plants to grow. We find that plants don't need gravity to grow. They need the light, and it's the light that makes all the difference. And NASA's developed the capabilities to give plants the right light through LEDs. And so we can trick the plant to grow not only during the day when the sunlight is available, but turn on the LEDs and force them to grow that night. And so we're entering an era for which we can grow using vertical farming and using these new ideas of irradiating the plants with the right spectrum of light, the ability to have twice the yield in a growing season. Now this, of course, is absolutely essential when we go to the places like the moon and Mars. But these activities now are actually becoming standard in a number of places. Greenland, there's a town in Greenland that has a vertical farm where they are producing produce year-round in their vertical farm in Greenland. And they're starting to do this in the desert in the Middle East. So the things that we're doing in space just has enormous ramifications. So what about the future? Since I only have a few minutes left, I can see the tug almost happening now. Well, the future is incredibly bright. We know that the International Space Station, which is getting old, it's starting to leak. There are all kinds of wear and tear that happens on it, is going to be replaced by several commercial space stations. Let me tell you the ones that are being planned. The ones that are currently being planned are Axiom Station by Axiom, Orbital Reef from Blue Origin, Starlab by a conglomeration of NanoRacks, Voyager, and Lockheed Martin, and Haven from a company called VAST. These companies are now building a framework for which they're going to pick up the research that NASA has started, that fundamental foundation, and build on that for a future. They are going to be doing individual research, but also manufacturing and also tourism. Yeah, you heard me right. May not happen to us, but maybe your kids or your grandkids will spend a vacation in space. Space hotels may be on the horizon. As we're able to actually get cheaper and cheaper to get into space and the launch costs go down, that's a reality. And now you don't just have type AAA, top-of-the-line astronauts. You have normal people living and working in space. What do you need to support them? Space hospitals. So there will be hospitals in space. I perceive that we will discover some things and some diseases that we can cure by only going into space. And that research is left to be done, and we can do it. For example, right now, if you want to grow an organ, you grow it in a petri dish, and it's only two-dimensional. In space, we can grow a heart. Okay? We can take your stem cells, trick them into making a heart, and begin the process of growing a heart, a liver, other types of organs that are uniquely yours. Grow them in space, send them down, and have them put in, and eliminate the enormous amount of drugs that you have to take to fool your immune system that you have a foreign object in your body, because it's not foreign, it's you. These are just a few things on the horizon, and I am looking forward to this era. The life research can't happen fast enough, as far as I'm concerned, because I've always told my daughter I plan to live to 150. The bottom line is we have known for some time that space is very important for the survival of this species. And now we're beginning the realization that it's very important for us in the area of human health and well-being and long, productive lives. Chemistry emerges as the integrating force that's linking the physics, the biology, and many of these other fields together. And there is no better place to perform them than the right place, doing the right thing in space. Thank you very much.